Hi, it's Mr. Mass here. Just stepped outside, walking around in my backyard. A little chilly out this morning. I know it's only April, but not having to wake up early in the morning for school kind of puts me in the mood for summer. I feel like it should be a lot warmer outside. So what we're talking about today is a little bit of HVAC. All right, so I want to be able to use this guy right here. That is our air conditioning unit. Unfortunately, we've been using a little bit too much of our furnace. This guy right here, with it being a little chilly out here, and I'm in shorts and a t-shirt, and it's only about 45. Little rainy and windy too. I'm gonna head back inside real quick. But like I said, we're gonna talk a little bit about HVAC, but don't mistake this for an HVAC lesson. This actually has a lot to do with math, because HVAC depends a lot on volume. You have to make sure that your air conditioner and your furnace is large enough and has enough power to heat or cool your entire house. And as mentioned, that depends on the volume or how much space is inside of your house that needs to be heated or cooled. We are going to start off talking about volumes of prisms. And before we can obviously talk about the volume of a prism, we got to talk about what a prism really is. All right, so a prism is a solid three-dimensional shape with two identical parallel polygon bases. Now that's the extremely important part. Two identical, and perhaps a better word to use is congruent. So two congruent and parallel polygon bases. All right, and I'm going to skip this part for a second. I'm going to come back to it. But if you look at these prisms down here, here's a triangle, and then on the other side, there's another triangle. Now you can't see it, but you can assume that it's there. Those triangles are congruent. With a rectangular prism, you can see this rectangle right here would be the same as this rectangle over here, congruent and parallel to each other. This pink object, 1, 2, 3, 4, 5 different sides, so that's a pentagonal prism. So it has a pentagon here, and in the back there is a congruent or identical pentagon that is parallel to the other one. Same with all of these. All right, so this square and the square in back are congruent. This hexagon and the hexagon in the back are congruent. And this octagon and the octagon in the back are congruent and parallel, which is why these are prisms. All right, and if you also look, prisms are named for the shape of their base. So this is called a triangular prism because those two sides that are congruent and parallel are triangles. This is called a pentagonal prism because the two sides that are congruent and parallel are pentagons. Now going back up here real quick, in a right prism, and honestly we're only going to be dealing with right prisms. We're not going to talk about oblique prisms. A right prism, all the other faces are rectangles. So you see the three other faces of this triangular prism are rectangles. Obviously everything in a rectangular prism are rectangles, but all the other sides in a pentagonal prism are rectangles. And this is where we have to be very careful in identifying the bases, because even though this rectangle and the rectangle right next to it are probably congruent to each other, they are not parallel. All right, so because they are not parallel, this is not a rectangular prism, this is a pentagonal prism. All right, same thing with the hexagonal prism. All right, yes, it's true that this side right here, this top rectangle and the bottom rectangle are congruent, and heck, they're also parallel, but all of the other faces have to be rectangles. And if we try to consider this rectangle and this rectangle on the bottom as the bases, this front side right here, the hexagon, that's not a rectangle, which is why we can't call this a rectangular prism. We have to call it a hexagonal prism because of these bases are parallel, the hexagon and the other hexagon, and all the other sides, all the other faces are rectangles. Now that we have identified what a prism is, now let's get into the meat and potatoes of this lesson, the volume of a prism. So the volume of a prism is capital BH. And this should be a little bit of review from literacy. Remember, capital B is the area of the base. Typically when we see a capital letter in a formula, that means that sometimes a little extra work has to be done. So there's not just going to be a number given to you. You might have to use a formula within a formula. For example, if the triangular prism has a base of a triangle, we're going to have to use the formula for the area of a triangle, which is 1/2 base times height, to find what capital B is, and then use the h, whatever that height might be, to calculate the volume. For a rectangular prism, use length times width to find the area of that rectangle and then multiply it by h. We're not going to look too much into areas of pentagons and areas of hexagons. That's a little bit higher level math. Once you get into geometry, you'll deal with that. But the same idea. If you could find the area of the pentagon, you just multiply it by h. Now, I also need to talk about h. In all of these examples, the base happens to be on the bottom. So it makes sense to think of h as the height, but the h actually has to represent the distance between the bases, because prisms don't always have the base on the bottom. If you flip these around like that, they're still prisms. They are still, like, the volumes didn't change just because I turned the orientation of it. But now you'll notice that the bases are on the sides, not the bottom. So we can't think of the height as going from top to bottom here. We have to think of the height as going from one base to the other base. So you have to keep that in mind when you're trying to determine what you're going to put in for h. I've got a couple props with me here to talk about prisms and how to find the volume. First thing is the Legos. I think the Legos are a really easy way to demonstrate our volume of a prism here. Remember, capital B is the area of the base, and h represents the distance between the bases. All right, so keeping that in mind, if I look at my stack of Legos here, this is a rectangular prism. All of the sides are rectangles. I'm going to go ahead and use this part as the base. As you can see, it is congruent and parallel to the bottom part. And I'm going to go ahead and remove one of the bases here. And what makes Legos really good is you can kind of use the little dots as the units. So we call this a 2x4 Lego, obviously because we've got 2 going this way and 4 going this way. All right. So if I looked at this as the base to find the volume, where we need to first figure out what B is, the area of the base. Area of a rectangle is length times width. So we're taking 2 times 4, and altogether we have 8 of these. All right. Now, if this is the base, and now we look at this as the height, think of each Lego as 1 unit of the height. So the distance between the bottom base and the top base, we've got 1, 2, 3, 4, 5, 6, 7 of them. So we would take 8 times 7, and altogether we would have 56 cubic units. All right. Area is just the squares, but volume deals with cubic units, which is important to remember here. All right. So this is the idea of why it's important to find the area of the base first, and then it's really just like stacking on top of each other. How many of these do we actually have? We've got 1, 2, 3, 4, 5, 6, 7 of them. So that's why the volume is figure out the area of the base and then just multiply it by the height. All right. This is a very, very, very important rectangular prism because if you look around us, the whole world is mainly made up of rectangular prisms. Buildings, the room that I'm sitting in right now, a lot of computers, iPads, phones, basically rectangular prisms. Fish tank, you know, a lot of rectangular prisms around here. Not everything is a rectangular prism, but this is a prism. We've got a hexagon on that side, a hexagon on that side. They are congruent to each other, they are parallel, and all of the other sides are rectangles. Now normally it's hard to kind of see, but I try to draw some lines so you can see the rectangle on each of these sides. And this is why it's also important to recognize that the height isn't just top to bottom, because if I'm looking at this pencil right here, you might be inclined to think that the height goes from here to the top here. All right, but the bases aren't on the bottom, so you have to think of the height as this direction, this direction right here. If I were to put the base on the bottom, like this, then you could think of this as the height. All right. Now, not a prism because the side isn't made of a polygon, but if you look at this and this as the bases, they are congruent and parallel to each other. So you could use the same concept for this as well. You would just have to find the area of this part and multiply it by the height. All right, and this really probably wouldn't be that difficult. Probably like a rectangle in the middle, and then you put the two curves together, you get a circle. So you just have to add the area of that circle and the area of that rectangle. Also want to talk about this. All right, so we could have a base here, but this would not be as easy as taking the area of the base and multiplying it by the height, because this is not congruent to this, which is why cups are usually stackable. All right, so you have to be careful of using this formula for everything, because it doesn't work for everything. Only if the bases are indeed congruent to each other, which in this case they are not. All right, and this is actually called a truncated cone. I mentioned this in an earlier video because it would go to a point up here eventually. So we could use the formula for a volume of a cone, which will be coming up probably next week. We are only going to be looking at the volume of rectangular prisms and triangular prisms. So let's take a look at the types of examples when we're looking at. So here, the most basic, rectangular prism. A lot of people have seen the volume of this as length times width times height, which is perfectly acceptable to use. And the reason why that is if we look at capital B, where capital B is the volume of the base here is a rectangle, which is length times width. So that's why it's okay to just do length times width times height. The issue is when we say length times width times height for volume, almost everybody automatically thinks that the volume for every shape that you possibly get for every prism is length times width times height. So that's why I try to avoid saying length times width times height, which is why I prefer saying the area of the base times the height. So for this particular example, we're going to go ahead and use this bottom part here as the base, because we typically think of the base on the bottom. So when we do that, the area of the base is 9 times 8, which is 72. All right, and then when we substitute that 72 in for B, the distance between the two bases here, so these would represent the two bases now, the distance between those is 6, so we would take 72 times 6 here. All right, and 72 times 6 gives us 432. And as we mentioned, volume talks about the number of cubes inside of this. All right, so if we look at, let me try to draw that again. If we look at what we're really talking about, here's a square. I'm going to try to make this into a little cube here. This is what we're basically trying to figure out. How many of these little cubes could we fit inside of that rectangular prism? All right, and this is saying 432 of those cubic meters could fit inside of there. That also being said, we can look at this mathematically as well. Every time that we multiplied these numbers, let me go ahead and erase this real quick. When we multiplied 9, we're actually taking 9 meters times 8 meters, which is 72 times meters, which was 72 meters squared. And then when we took that 72 meters squared times 6 meters, we're really looking at 72 times 6 times meters squared times meters. And meters squared times meters, technically there is a 1 as an exponent there. Add those two exponents, that's how we got cubic meters out of that. So that's why it was 432 cubic meters for volume. So just regular lengths, use your standard units, meters, feet, inches, and so on. If you're looking at area, like this was the area of the base, you're using square units, because talking about the number of squares that you can fit inside of that two-dimensional figure. When we go to volume, so the amount of space, it's called capacity. So the capacity of a three-dimensional object talks about cubic units. So what we have right here. And the last type of problem that we're going to look at is the volume of a triangular prism. So once again, these prisms are named by the shape of their base. And you have to be careful not to think of the base as the bottom part here. Remember, the bases are congruent and they are parallel to each other, which is why this triangle and this triangle back here would be considered the bases. All right, so a lot of things that we have to think about in this case. All right, so first of all, capital B here, we're looking at the area of a triangle. And the area of a triangle, if you remember, is 1/2 base times height. And when we're looking for the base and the height, we look for that right angle. Whatever two dimensions make up that right angle are what we're going to use for our base and our height here. So the area is 1/2 times 9 times 8. And as we mentioned earlier, a lot of times, if I have an even number, I'm going to take half of that even number. So I'm going to take 1/2 of 8 to start off with, which is 4, and then take 4 times 9 and get 36. And we could call that 36 inches squared. All right, so I'm going to continue on here. So now that we have the area of the base, volume is area of the base times the height. So we can now substitute that 36. And I'm going to go ahead and leave that 36 inches squared in for the base. And then remember, the height is the distance between the bases. Some people are inclined to use this 8 for the height, but that's not the height of the prism. That was the height of just the triangle. So the height of the prism is 10 inches. So when I'm substituting my appropriate values in here, I'm going to put 10 inches in for the height of the prism, and 36 times 10 is 360. Inches squared times inches gives me inches cubed. So the volume for this one is 360 inches cubed. And don't forget, if you look on Alex, they're going to look at giving you different options for your answers in terms of the units that you use. Every time that you're doing volume, it is going to be inches cubed based on taking that dimension multiplied by itself 3 times. The last thing I want to talk about is where we started, the HVAC, heating, ventilation, and air conditioning. I just did a Google search of floor plans, and so these are floor plans of houses. And as mentioned, to find the volume of something, you can find the area of the base and just multiply it by the height. So a typical house is made up of a bunch of polygons, typically a bunch of rectangles, as you see here. There are very few houses. This one's got a little bit of a half of a octagon there. But for the most part, everything is just squares and rectangles, which makes it pretty easy to find the area. And then you would just have to multiply that area of the foot, which would represent the base, by the ceiling height. Now, most houses have flat ceilings that make everything a rectangular prism, so it makes it simple to calculate the volume. However, some houses have vaulted ceilings, all right? And when you have a vaulted ceiling, that kind of adds a triangular prism onto the top. So these are examples of vaulted ceilings, and you'll see it's not just a rectangular prism anymore. So if you're trying to consider the size of air conditioner or furnace that you need to heat this entire space, it's not as easy as just taking that floor plan and multiplying it by the height of the ceiling, because it's not a rectangular prism anymore. All right, we're actually adding a triangular prism, as I mentioned, and I'm going to do my best to try to demonstrate that here. So a typical house or a typical room is going to look just like this. All right, so just a rectangular prism. But when you add the vaulted ceiling onto that, you'll see how you're adding a triangular prism onto that as well. So you would then have to consider your bases here. You would have to consider this triangle and this triangle as your base, calculate the area of that base, and then use this length right here as your height. So you're doing the volume of the rectangular prism, that is kind of the room itself, and then the volume of that extra space of the triangular prism as well. Your assignment for this lesson is called Volume of Prisms on alex.com. It is 10 questions long, worth 10 points, and if you need any help, go ahead and Zoom with me during your class time or during my office hours, and those links are in your email.